Hi guys. So I'm away today, as you can hear. My voice is not so good, but because I'm a crazy teacher, I'm still going to film a lesson, and I am going to teach you all about circle properties. So make sure that your volume is up high, and we'll see how long my voice lasts. Okay, so this is lesson 6.8. We're going to be talking about circle properties. So first of all, I'd like to talk about lots of different terms that we have and definitions for the parts of a circle. Some of them you're familiar with already, which is great, but there's a couple more that you'll see in further years of math in high school. So let's just make sure you know them. So the first one is circumference. So the circumference is the perimeter all the way around the circle. The radius and the diameter. The diameter is a line that goes from one side of the circle all the way through the center and then to the other side. If it actually doesn't go through the center and it goes from one side of the circle to the other, it's called a chord. So you'll notice that I have an example of a chord right here where it goes from one side of the circle to the other, but not through the middle of the circle. Now, if you have a line from the middle of the circle to the outside of the circle, that's called the radius. So you see, I actually have 1, 2, and 3 radii here. Yeah, that's how you say radius, but plural, you say radii. Okay, so let's see, a secant and a tangent. Let's just talk about those two. As we talked about chord already, a tangent is a line outside of the circle. It touches and skims the edge of the circle and touches only once, whereas a secant will go right through the circle and touch twice. So it's kind of like a chord, but it keeps going on and on forever. Okay, now a central angle is an angle that's between two radii. So see how you have a radius here and a radius here? A central angle is right in between. Okay, so this could also be considered a central angle. An inscribed angle is between two chords. So I made another little chord right here. So that's called an inscribed angle. Okay, now that you know all about the different names and parts, let me talk to you about 3 properties, and that's pretty much it for this video. So one of the circle rules or properties is called the tangent radius property. And what it means is when you have a tangent, so a line that skims the edge of a circle, and a radius, they're always going to touch at a 90 degrees. And so what I have here is the line CP. So we call it a line segment by putting a line on top of it. So this tells you it's a line segment is perpendicular. So this symbol right here, you'll see it a lot in grade 10, is a symbol for perpendicular. And what that means is the orange and the green line touch at a 90-degree angle. So those two lines are perpendicular to each other. Okay, so CP is perpendicular to tangent L. Now, again, the rule with this property is they'll meet at a 90 degrees. So if I ever have a question where I have a tangent and a radius, and they're asking you find this unknown angle A, you know that the inside of a triangle, this corner, this corner, this corner, they all have to add up to 180. And now that you know that this corner, even though there's nothing there, you know because of this property, it's a 90 degrees. Then you're just going to go the entire total 180 minus 54 minus 90 will give you that last angle A. Now remember, in each step that you're writing your answers, I want to see the variable A. Okay, so I need to see your letter. You're going to put angle symbols, okay, and don't forget your degree signs at each step. And at the very end, you're going to tell me your conclusion, how you found your answer. So we're just going to say it was a tangent radius property. Okay, going on to this question. So here I see a tangent and I see a radius, and I can find all the rest. In fact, immediately I know because of the rule, the property angle T is right away 90 degrees. And because that's 90 degrees, that 90 degrees, that 46, and that E must add up to 180. So I'm going to find that next. Angle E is 180 minus 90 minus 46, which is 44 degrees. And the very last one, F, well, that's all the way in this triangle, but we know this corner right here is also a 90 degrees because of the tangent radius property. So I'm just, again, going to go 180 minus 90 minus 25, and that last angle is going to be my F, which is 65. Now, when you're finding lots of different letters, you want to, at the very end, put a therefore sentence that just lists all your final answers, or you can put a box around each of your final answers. It just makes it easier for your teacher to find your answers. Okay, now I didn't write my conclusion, my reason, tangent, radius property because I just ran out of room, but I expect you guys to do it. Okay, the next property is called the perpendicular bisector. So perpendicular, one more time, means at a 90 degrees. So these two lines meet at a 90 degrees, and they're going to bisect each other. Bi means two. Sect means cut. So notice that the radius, this line, will cut this chord, this pink line, in two pieces, and those two pieces in pink are equal. So I put two little ticks here to show you that they're equal in length. Okay, and remember, perpendicular means they also cut at a 90-degree angle. All right, so that's just a rule. AB, so AB, oh, I forgot the line. I should have put the line segment lines on top. Okay, communication marks off. Is equal to BC. So these two lines are equal to each other in length. Now, let's introduce a three-letter naming system, CBD. CBD is referring to the angle right in the middle at B. So when you see three letters, you're talking about just the middle letter, what you see at the middle letter. So this is going to be 90 degrees. Now, we also have another one that CBD is going to equal to ABD because this is also going to be a 90 degrees. All right, again, because of this perpendicular bisector rule, but also because supplementary angles means along a straight line. Both this angle and this angle, these two should add up to 180. So if this is 90, that must also be 90 degrees. Okay, so let's try using that property in order to figure out this question. Here is the radius, I put it in orange, and this is a chord in pink. And so if you have both of those, you know that the property says this is going to be a 90 degrees and both these pink lines are equal in length. So if I want to find C, I'm going to take 180 minus 90 minus 33 and I get the answer 57. And that's going to be because of perpendicular bisectors. Okay, so it's a little bit similar, but a little bit different than the previous property. The previous property dealt with a tangent outside of the circle, whereas this property deals with a chord inside the circle. Okay, so here is my radius once again. In fact, this is also a radius, and this is also a radius, but this is not. This is a chord. Okay, so because of the perpendicular bisector property, they're going to meet at 90 degrees and they're going to split both of these pink pieces in half. Okay, and so if you want to find D, you can go 180 minus 36 minus 90 and you'll get D of 54 degrees. And because you can do the same thing where this is a 90 degrees and try to find your way over here, but I'm noticing because this is a radius, it should be the same length as this one. And because this side is the same as this side, this 36 is actually the same as this 36. Oh, I totally messed up. I'm going to blame that because I'm feeling a little bit off the weather right now. This should say 36. My bad. It's an isosceles triangle. These two angles are the same. Please make that correction. My mistake. I'm sorry. Okay, the very last one is called a diameter circumference property. And so here is a diameter, and if you have any two chords that connect from the diameter to an edge on the circumference back to the diameter, that angle right at the circumference is always going to be a 90. So ABD is going to be 90 degrees, and ACD is going to be 90 degrees as well. So again, here is your diameter. Here are your two chords that touch either sides of the diameter and touch the circumference. This is going to be a 90 degrees. So if I want to find x, I'm just going to take 180 minus these two, and I'm going to get an answer of 25 degrees and put my reason or my conclusion, diameter circumference property. So this is probably the trickiest one. I have the diameter in orange right across, and I have my set of chords over here, and another exact same set of chords over here. And they said that these two lengths are going to be the same. So it's almost like this pink triangle and this pink triangle are the same. Now the 76 degrees, I believe, is for this entire curved side. So both this corner, this little corner, and this little corner. So what I decided to do if I want x is I want this tiny corner right here, and I'm going to half the 76. Now let me introduce you to a new symbol. There is no letter here, and so there's actually a Greek symbol called theta. Okay, so theta is a symbol, it's a Greek letter. It stands for an angle, any angle. You'll see that a lot when you do trigonometry in grade 10. So I figured I might just throw that in there in this video. So this angle ended up to be 38. Now if I have this little corner, and I know because of the diameter circumference property that this is going to be a 90 degrees, I'm going to take 180 minus 38 minus 90 degrees, and I will get x. All right, so I think that's as much as my voice will allow. The last page is for you to do your homework. Okay, and again, if you have any questions, you can either comment on this video or you can email me if you're my student. If you're not, hi, I'm not going to send out my personal email, sorry. Okay, so you guys can comment on the video below. Have a great day.